An isolated rail car of mass m is moving along a straight frictionless track at an initial velocity v naught. Okay, the car is passing under a bridge. So suppose there is a car over here and there is a bridge above it. Okay, the car is passing under a bridge when a crate filled with n bowling balls, each of mass m, is dropped from the bridge into the bed of the rail car. Okay, so there are many balls which are being thrown from certain height, okay, into this car. Okay, the crate splits open and the bowling balls bounce around inside the car rail, but none of them fall out. Okay, everything is inside the car. Okay, all the balls are inside the car. But none of them fall out. Is the momentum of the rail car plus the bowling balls conserved in this collision? Okay, now first of all, understand that when I consider these bowling balls, okay, when they land inside the crate, okay, since none of them fall out of the crate in any of the direction, I can say that these balls in the horizontal direction have gained velocity. Okay, it has gained velocity equal to the velocity of the car. Okay, they have gained velocity with equal to velocity of the car after certain time. Okay, after certain time they have gained the velocity equal to that of the car. Okay, so we have to find out whether the momentum is conserved, completely conserved, or only in vertical or in horizontal, or none of them. Okay, first of all, understand that in the vertical, since none of the ball fall out, it means that in the vertical I can say that the momentum is not conserved, and the momentum will only be conserved in the horizontal direction. And why the momentum will be conserved in only in the horizontal direction? That is the direction parallel to the tracks. Okay, why is it conserved in the direction parallel to the tracks? It is very much simple. I can say that as the mass goes on adding over here with whatever velocity it may be, okay, with whatever velocity it may be, the car will never gain a velocity in the vertical direction. Okay, the car will never gain velocity in the vertical direction. So in vertical it is not conserved, but in horizontal direction I can say that the initial momentum of the car, let the mass of the car be m, the momentum of the car will be equal to m into u, or m into v naught. If initial velocity is v naught, it will be equal to m v naught. It will be equal to m plus nm into v. Okay, where v is the final velocity of the car as well as all the balls. Okay, so I can say that the correct option is over here, option number C. That is, the momentum is conserved only parallel to the tracks.